Hello there, and welcome to this gentle corner where big questions meet soft contemplation, where wonder wraps around you like a favorite blanket, and curiosity finds its most comfortable chair. Tonight we're embarking on a journey into one of the most profound mysteries that has ever tickled human consciousness. Is time even real? Now, before you start checking your phone or glancing at that clock on the wall, before you begin to feel any urgency about the answer, let me invite you to settle in completely, because this is a question that's best approached with the kind of leisurely patience that time itself seems to both demand and deny. You check the clock throughout your day, feel seconds tick by like tiny heartbeats of the universe. Remember yesterday's conversations with startling clarity, plan tomorrow's adventures with hopeful anticipation. But what if all of this, every single temporal experience you've ever had, is actually a beautiful, elaborate, utterly convincing illusion? What if the very thing that seems to govern every moment of your existence, that ages you and rushes you, and sometimes, mercifully, slows down when you need it most? What if time is more like a dream than a river? More like a story your brain tells itself than a fundamental fact about reality? Before we drift into this mystery together, before we let our minds wander down paths that might seem strange at first but will hopefully feel like coming home by the end, I'd love to know where you're listening from tonight, and what time your clock, that faithful timekeeper beside your bed or glowing on your screen, claims it is right at this very moment. Isn't it curious, almost magical when you think about it, that we're all experiencing this particular now together, you and I? Despite being scattered across different time zones, different continents, different slices of what we call the present moment. You might be listening in the early morning, with sunlight just beginning to paint your room golden. Or perhaps it's deep night where you are, with darkness wrapped around your home like a protective blanket. Or maybe it's that peculiar in-between time, twilight or dawn, when the world seems suspended between what was and what will be. Yet here we are, sharing this moment, this exploration, this gentle questioning of something so fundamental that most of us never think to question it at all. The question we're exploring tonight might sound unsettling at first, perhaps even alarming if you think about it too quickly, or with too much intensity. But I promise you there's something wonderfully liberating, almost magical, about discovering that the thing you thought was chasing you, the thing you thought you were racing against, the thing that sometimes feels like it's slipping through your fingers like water, might not be quite what you thought it was. There's tremendous peace to be found in realizing that time, this invisible conductor of the orchestra of your life, might be more of a gentle suggestion than a stern taskmaster. We'll wander through ancient wisdom and modern physics tonight, through the corridors of your brain and the vast expanses of the cosmos, through moments that last forever and eternities that pass in the blink of an eye. We'll meet philosophers who puzzled over time's nature thousands of years ago, scientists who turned our understanding upside down just over a century ago, and researchers today who are discovering that consciousness and time might be far more intertwined than anyone ever imagined. But don't worry about remembering every detail, about taking notes, or trying to grasp every concept with full clarity. This isn't a test you need to pass or a puzzle you need to solve completely. Think of it more like watching clouds drift across the sky, like listening to a piece of music that sometimes makes perfect sense and sometimes just feels beautiful, like having a conversation with an old friend who happens to know some fascinating things about the nature of reality, but is in no hurry to convince you of anything. Some of what we explore tonight might challenge ideas you've held since childhood, might make you question assumptions you didn't even know you were making, and that's perfectly fine. Questions, after all, are often more interesting than answers, and wondering is frequently more valuable than knowing. The goal isn't to solve the mystery of time tonight, though we'll certainly try to understand it better. The goal is to spend some peaceful moments together contemplating something magnificent and strange, something that touches every second of your life yet remains beautifully, mysteriously elusive. So wherever you are in this vast, timeless, time-obsessed world of ours, whatever your clocks might be claiming about this particular moment, let yourself sink a little deeper into comfort. Let your breathing slow and your thoughts soften. And let's begin this gentle journey into one of the most beautiful questions humans have ever asked. Because somewhere between the tick of your clock and the beat of your heart, somewhere between memory and anticipation, between sleeping and waking, lies a mystery worth exploring, a question worth asking, and perhaps, just perhaps, a kind of peace worth finding. Time feels utterly, completely, undeniably real, doesn't it? So real that questioning its existence might seem like asking whether your favorite cup of tea actually exists, or whether the pillow beneath your head is really there supporting you, or whether the steady rhythm of your breathing is anything more than a pleasant fiction. From the moment you wake up, often to the insistent sound of an alarm clock that seems convinced it knows what time means, until the moment you drift off to sleep, your entire day unfolds according to time's supposed dictates, its rhythms, its demands, its gentle or not so gentle prodding. You wake at a certain hour, marked precisely by numbers glowing on a screen or hands pointing at specific positions on a circle, and immediately your brain begins its familiar dance with temporal reality. You check the time, calculate how many minutes until you absolutely must get out of bed. Perhaps negotiate with time itself for just 5 more minutes of warmth and comfort and blessed unconsciousness. You eat breakfast at breakfast time, not because your body necessarily craves food at that particular moment, but because the clock and society and your internal sense of proper scheduling all agree that morning means morning food, just as evening means evening food, and the two should never meet except in the most rebellious of late-night snacking sessions. You work during work hours, those arbitrary but seemingly sacred temporal containers that humans have agreed upon, those boxes of time that we fill with productivity and purpose, and the occasional daydream about being somewhere else entirely. You meet friends at agreed-upon times, and if someone is late, if their personal relationship with time differs from yours by even 15 minutes, you might feel anything from mild annoyance to genuine concern, as though they have somehow violated a fundamental law of nature rather than simply experienced time differently than you expected them to. But here's something curious, something that starts to hint at the strangeness lurking beneath time's seemingly solid surface. That drumbeat of time, that steady tick-tock that seems to govern everything, actually changes tempo constantly throughout your day, throughout your life, in ways that should be impossible if time were truly the fixed, absolute, flowing river we imagine it to be. 5 minutes waiting for a friend who's running late can stretch like a small eternity, each second dragging by with the weight of honey pouring from a jar, making you glance at your phone again and again as though checking might somehow speed up time's passage or reveal that your timepiece is playing tricks on you. Meanwhile, an hour spent reading a book that completely captivates your imagination, that draws you into another world entirely, can vanish like morning mist, leaving you blinking in surprise when you finally surface from those pages, wondering how the numbers on your clock could have jumped forward so dramatically when you were certain that only minutes had passed. Time, apparently, has moods, has preferences, has a sense of humor, speeding up when you're happy and slowing down when you're bored, racing ahead when you're in love and crawling when you're anxious, as though it's less a fundamental force of nature and more a mischievous companion who enjoys playing games with your perception. Your brain, that marvelous 3-pound universe nestled safely in your skull, is constantly creating time from attention and memory, from expectation and experience, stitching individual moments together into the seamless story you call your day or your life. Without realizing it, without any conscious effort or awareness, your neural networks are working around the clock, so to speak, to maintain the illusion of flowing time, the sense that there's a coherent past that led to this present moment, and a future that's waiting patiently somewhere ahead of you. When you're fully absorbed in something you love, when you're in what psychologists call a flow state, your brain essentially stops keeping track of time altogether. It's too busy, too engaged, too delighted with the present moment to bother monitoring the passage of minutes and hours. Your internal timekeeper, that part of your mind that usually counts seconds like a faithful metronome, goes quiet, takes a break, leaves you floating in a kind of temporal weightlessness where only the activity itself matters, where past and future fade into irrelevance. And all that exists is this moment, this breath, this word, this note, this brush stroke, this perfect, timeless now. Conversely, when you're bored, when your mind has nothing particularly engaging to focus on, that same internal timekeeper becomes hyperactive, like an anxious conductor frantically waving his baton at an orchestra that's playing far too slowly. Every second gets counted, measured, felt, experienced with excruciating clarity. You become aware of time passing in a way that makes it feel almost physical, almost heavy, as though you're wading through temporal molasses while carrying a clock that's determined to remind you of every single tick. The clock on your wall, meanwhile, continues its mechanical march with perfect regularity, each second identical to the last, each minute an exact copy of every other minute that has ever existed or ever will exist. It doesn't care whether you're bored or excited, whether you're falling in love or falling asleep, whether you're 5 years old and summers stretch on forever, or 50 years old and decades seem to blur together like watercolors in the rain. The clock ticks steadily, impartially, indifferently, while your experience of those very same ticks varies wildly, dramatically, mysteriously. This disconnect between measured time and experienced time should give us pause, should make us wonder whether we've been thinking about time all wrong, whether the thing we measure so precisely with our atomic clocks and digital displays is actually the same thing we live and breathe and feel in our bones. Your personal relationship with time is already far stranger, far more flexible, far more subjective than most people realize, which makes the question of whether time exists at all feel less like philosophical nonsense and more like a perfectly reasonable thing to wonder about on a quiet evening when the world has settled down and your mind is free to wander, wherever curiosity might lead it. Long before modern physics began dismantling our assumptions about reality, long before scientists with their equations and experiments started suggesting that time might be more fluid than we imagined, ancient philosophers and mystics were already wrestling with this most fundamental of mysteries, already sensing that something wasn't quite right with our everyday understanding of temporal flow. These weren't primitive minds struggling with concepts too advanced for their era. These were some of humanity's most brilliant thinkers, approaching the mystery of time with fresh eyes and profound intuition, unburdened by the mechanical clockwork worldview that would later make time seem so solid, so absolute, so unquestionably real. Augustine of Hippo, writing in the 4th century, articulated what might be the most honest thing anyone has ever said about time. What then is time? If no one asks me, I know. If someone asks, and I try to explain, I do not know. There's something beautifully humble about this admission, something that captures the essential mystery we're still grappling with today. Augustine understood that time is simultaneously the most intimate and familiar aspect of human experience and the most elusive concept we've ever tried to grasp with language or logic. We live completely immersed in time, yet the moment we try to explain what it actually is, it slips through our fingers like water, like smoke, like dreams upon waking. Augustine went further, suggesting that the past exists only in memory, the future only in expectation, and the present is a knife edge so thin that it has no duration at all. If you think about this carefully, it becomes rather startling. The past, all those moments you remember so vividly, your childhood summers, and first heartbreaks and yesterday's conversations, exist nowhere except in the neural patterns of your brain, in the stories you tell yourself about what happened. The future, all those plans and dreams and appointments in your calendar, exists nowhere except in your imagination, in your hopes and fears about what might come to pass. And the present, this very moment, that seems so real and immediate, is gone before you can even identify it, replaced by another present that's already dissolving into past as you notice it. The ancient Greeks had a particularly sophisticated understanding of time's dual nature. They distinguished between two completely different temporal experiences, chronos and kairos. Chronos was quantitative time, measured time, the relentless tick-tock of sequential moments that we're so familiar with today. This is clock time, calendar time, the time of schedules and deadlines and aging. But kairos was qualitative time, the right time, the supreme moment, time as experienced from within rather than measured from without. Kairos is the time of falling in love, the time of creative inspiration, the time when everything suddenly makes perfect sense, the time that seems to exist outside of time altogether. Think about moments in your own life when Kairos broke through the ordinary flow of Chronos. Perhaps it was watching a sunset that seemed to last forever, or having a conversation so absorbing that hours passed like minutes, or experiencing that perfect stillness that sometimes comes in the middle of a busy day, when everything stops and you're simply, completely present. These moments feel more real than regular time, more meaningful than the minutes and hours that surround them, as though you've temporarily stepped outside the normal flow of temporal experience into something deeper, something more fundamental. Buddhist philosophy, developing parallel insights in another part of the world, arrived at even more radical conclusions about time's nature. In Buddhist thought, time is Maya, illusion, part of the veil of appearances that conceals the true nature of reality. This doesn't mean time is unreal in the sense of being hallucinatory or false, but rather that our ordinary experience of temporal flow is a kind of constructed interpretation, a way our minds organize and make sense of something that, at its deepest level, might be quite different from how it appears. The Buddhist concept of impermanence, the idea that all things are constantly changing and that nothing maintains a fixed identity across time, points toward a view of reality as pure process, pure becoming, without any solid entities that persist through temporal change. In this understanding, there's no thing that moves through time. There's only movement, only change, only the continuous arising and passing away of moments of experience. Time becomes not a container in which events happen, but the very essence of what reality is. Constant transformation, endless flux, the dance of appearance and disappearance that makes up what we call existence. Indigenous cultures around the world have often maintained circular rather than linear concepts of time, seeing temporal reality as cyclical, seasonal, returning to itself in endless spirals, rather than marching forward in straight lines towards some distant destination. These aren't primitive misunderstandings of time's true nature, but sophisticated alternative models that emphasize time's relationship to natural rhythms, to the patterns of day and night, seasons and years, birth and death and renewal that characterize life on Earth. Many Native American traditions speak of time as a spiral, where past and future curve back to meet each other, where ancestors and descendants exist in the same eternal present, where what we call history is really a vast, ongoing ceremony in which all moments participate simultaneously. In these worldviews, time isn't something you move through, but something you participate in. Not a river flowing toward the ocean, but a great wheel turning in place, bringing all moments into relationship with each other. The dream time of Aboriginal Australian cultures presents perhaps the most radical alternative to linear time, describing a dimension where mythical events continue to happen eternally, where past and present and future collapse into a single, ongoing reality that can be accessed through ritual, through story, through proper relationship with the land itself. These aren't quaint primitive beliefs, but sophisticated metaphysical systems that suggest time might be fundamentally different from our everyday assumptions about temporal flow. What's remarkable is how these ancient intuitions about time's constructed nature, its subjectivity, its potential unreality, align so closely with what modern physics is discovering about temporal reality. These early philosophers and spiritual traditions, working without benefit of atomic clocks or particle accelerators or equations describing space-time curvature, somehow sensed that time was far stranger, far less solid, far more mysterious than it appears to our ordinary consciousness. They approach time with wonder rather than measurement, with questions rather than assumptions, and in doing so, they may have glimpsed something essential about reality's deepest nature that we're only now beginning to understand through our most advanced scientific theories. Then came Albert Einstein, walking quietly into the 20th century with wild hair and gentle eyes, carrying with him ideas so revolutionary that they would gently, permanently, completely shatter every assumption human beings had ever made about the nature of time and space and reality itself. Einstein wasn't trying to destroy our understanding of time. He was simply following mathematical logic wherever it led, asking innocent questions about the speed of light and the nature of motion. Questions that seemed straightforward enough, but turned out to have answers that would reshape our entire picture of the universe and our place within it. In 1905, when Einstein was just 26 years old and working as a patent clerk in Switzerland, probably spending his lunch breaks rewriting the fundamental laws of physics while his colleagues worried about more mundane matters, he published his special theory of relativity, a work that sounds technical and forbidding but is actually built around ideas so simple that anyone can understand them. The core insight was this: the laws of physics, including the speed of light, must be the same for all observers, regardless of how fast they're moving through space. This seems reasonable enough, almost obvious, until you start thinking through the implications. If light always travels at the same speed relative to every observer, something Einstein had reason to believe from the strange results of experiments with light and electromagnetic radiation, then some very peculiar things must be true about time and space. Imagine you're on a train traveling at nearly the speed of light, and you shine a flashlight forward. Common sense suggests that the light from your flashlight should move at the speed of light plus the speed of your train, just as throwing a ball forward from a moving car makes the ball travel faster relative to the ground. But Einstein realized that this can't be right. The speed of light must be the same whether you measure it from the train or from the platform. The only way this can work is if time itself behaves differently for observers moving at different speeds. This leads to one of the most mind-bending consequences of special relativity: time dilation. The discovery that time literally passes more slowly for objects moving at high speeds relative to stationary observers. This isn't a matter of perception or measurement error. Time actually, physically, measurably slows down as you approach the speed of light. If you were to board a spaceship and travel at 90% the speed of light for what feels like 1 year to you, when you return to Earth, you'd discover that more than 2 years had passed here. You would have aged 1 year while Earth aged 2. This phenomenon has been tested countless times and found to be absolutely, precisely, undeniably true. Atomic clocks flown around the world on jet airplanes tick slightly slower than identical clocks left on the ground. Not enough for you to notice in your daily life, but more than enough to prove that Einstein was right about time's flexibility. Particles in accelerators, moving at close to light speed, decay more slowly than they should according to their normal lifespans, living longer because time passes more slowly for them. GPS satellites orbiting Earth must have their clocks constantly adjusted because time moves faster for them in their weaker gravitational field and at their high orbital speeds. But perhaps even more startling than time dilation is the realization that there's no universal now, no cosmic present moment that all observers throughout the universe can agree upon. Events that appear simultaneous to one observer might occur at different times for someone moving at a different speed. This demolishes our intuitive notion of time as a universal flow that carries everything forward together. Instead, time becomes personal, relative, dependent on your motion through space. The present moment, that knife edge of experience that feels so immediate and shared, turns out to be different for every observer. This leads to the famous twin paradox, one of relativity's most fascinating thought experiments. Imagine identical twins, one of whom stays on Earth while the other travels to a distant star at near light speed. When the traveling twin returns, they will be younger than their earthbound sibling, not because they used better skincare or exercised more faithfully, but because time literally passed more slowly during their high-speed journey. The paradox isn't a contradiction in Einstein's theory. It's a feature, a mind-bending, but mathematically consistent consequence of taking seriously the idea that time is not absolute. 10 years later, Einstein expanded his insights into an even more comprehensive theory called general relativity, which revealed that gravity, too, warps the flow of time. In Einstein's mature understanding, gravity isn't a force pulling objects toward each other, but a curvature in the fabric of space-time itself, created by the presence of mass and energy. Massive objects like stars and planets bend space-time around them, like bowling balls placed on a stretched rubber sheet. And this curvature affects not just the motion of objects through space, but the passage of time itself. Time runs more slowly in stronger gravitational fields, a phenomenon called gravitational time dilation. This means that time passes slightly more slowly for your feet than for your head, because your feet are closer to Earth's gravitational center. The effect is tiny, measurable only with the most precise instruments, but it's real and constant. Clocks at the bottom of mountains tick more slowly than clocks at the peaks. Time at sea level passes more slowly than time at altitude. Your head is literally aging faster than your feet, though the difference amounts to mere nanoseconds over a human lifetime. Near extremely massive objects like black holes, these time distortions become dramatic. Close to a black hole's event horizon, time slows to a crawl compared to regions farther away. An observer watching someone fall toward a black hole would see them slow down and freeze at the edge, their image red-shifting and fading, but never quite disappearing. Meanwhile, the falling observer experiences time normally from their own perspective, but watches the rest of the universe speed up dramatically, seeing the future of the cosmos unfold in fast forward as they approach the point of no return. These aren't science fiction fantasies, but mathematical consequences of Einstein's equations, backed up by astronomical observations and precision measurements. We live in a universe where time is elastic, personal, dependent on motion and gravity, fundamentally different from the steady, universal clockwork that Newton imagined, and that still feels so intuitively correct in our everyday experience. Einstein himself understood the philosophical implications of his discoveries. He once wrote, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." He saw that his equations painted a picture of reality where all moments exist simultaneously in a four-dimensional space-time block, where time doesn't flow but simply is, where the experience of temporal passage emerges from our limited perspective as conscious observers embedded within this eternal, unchanging structure. Time, in Einstein's universe, becomes not a fundamental aspect of reality, but a consequence of our particular way of experiencing a deeper, timeless truth. Einstein's theories led to a startling picture of reality called the Bloch universe, a concept so strange and beautiful that it fundamentally changes how we might think about existence itself, about what it means to be alive, about the nature of past and future and the precious present moment you're experiencing right now as you listen to these words. Imagine, if you will, all of existence, every moment that has ever occurred or ever will occur, laid out like a vast, four-dimensional landscape that extends not just through the three dimensions of space we're familiar with, but through time as well, creating a structure so immense and complete that it contains every possible moment of reality. Your birth exists somewhere in this Bloch universe, a fixed coordinate in space-time that's just as real and permanent as any location you might visit on Earth. Your childhood exists there too, every scraped knee and birthday party and lazy summer afternoon when time seemed to stretch on forever, all preserved like photographs in an eternal album. This very moment, right now, as you listen to these words, and perhaps wonder whether any of this could possibly be true. This moment exists as a permanent feature of the block, a specific set of coordinates in the four-dimensional structure of reality. Your eventual death, that mysterious transition that seems so far in the future or perhaps uncomfortably close depending on your age and disposition, that too exists somewhere in the block universe, as real and fixed as any other event. This might sound disturbing at first, the idea that your entire life is already laid out, already complete, already existing in its entirety like a finished novel sitting on a shelf. But there's something oddly comforting about it too, something that suggests a kind of permanence to existence that our ordinary experience of flowing time doesn't capture. In this picture, time doesn't flow at all, despite the overwhelming feeling that it does. We don't move through time like boats traveling down a river. Instead, we simply exist at different coordinates within this eternal block, like houses scattered across a landscape. Your 5-year-old self isn't gone. It exists at a specific location in the block universe. Your future self, the person you'll be next year or in a decade, already exists at their own coordinates, experiencing their own moments with the same immediacy you experience this one. This isn't science fiction or mystical speculation. It follows naturally from Einstein's relativity. If there's no universal now, no cosmic present moment that all observers can agree upon, then all moments must be equally real. If simultaneity depends on your motion through space, then the distinction between past, present, and future becomes a matter of perspective rather than objective reality. Events that you consider to be in your past might be in the future for someone moving at a different speed, and events you think are in your future might already be present for another observer. Think about what this means for your understanding of memory and anticipation, those twin pillars of human consciousness that seem to connect us to past and future. When you remember your childhood, you might think you're accessing something that no longer exists, reaching back through time to touch moments that have vanished into the irretrievable past. But in the block universe, those moments are as present and real as this one. You're simply not located at those coordinates anymore. Your memories aren't records of things that used to exist. They're traces, echoes, connections between different parts of your extended four-dimensional existence. Similarly, when you worry about the future or make plans or dream about what might come to pass, you might think you're imagining possibilities that don't yet exist, scenarios that may or may not become real depending on choices you make and circumstances you encounter. But if the block universe is correct, then your future already exists as completely and definitely as your past. The person you'll be tomorrow morning, complete with whatever thoughts and feelings and experiences await them, is already there at tomorrow's coordinates, as real as you are right now. This raises profound questions about free will, about choice, about the nature of possibility itself. If your entire life already exists in the block universe, laid out from beginning to end like a completed sculpture, then in what sense do you make choices? Are you following a predetermined script, or are your choices themselves part of what makes the block universe the shape it is? These questions have puzzled philosophers and physicists for decades, and there's no easy answer. No simple way to reconcile the feeling of making free choices with the mathematical implication that those choices already exist in the structure of space-time. But perhaps the most beautiful aspect of the block universe is how it transforms our understanding of loss and impermanence. When someone you love dies, when a relationship ends, when a phase of your life concludes, our ordinary temporal perspective tells us that these things are gone forever, lost to the irreversible flow of time. But if all moments exist equally in the block universe, then nothing is ever truly lost. That perfect day with your loved ones still exists at its coordinates in space-time. Your childhood self, with all their wonder and innocence and boundless possibility, continues to exist in their own temporal location. Death itself becomes less absolute, less final. Your existence doesn't end when your biological processes cease. It simply has boundaries in the time dimension, just as it has boundaries in space. A sculpture doesn't cease to exist because it has edges. It exists completely within those edges. Similarly, A human life in the block universe doesn't disappear when it reaches its temporal boundaries. It exists eternally and completely within the four-dimensional region it occupies. Quantum mechanics adds another layer of strangeness to our understanding of time, bringing with it a collection of mysteries so profound and counterintuitive that even physicists who work with quantum theory every day admit they don't fully understand what it all means. At the smallest scales of reality, where individual particles dance according to rules that seem to mock common sense, time takes on characteristics that would seem impossible if they weren't demonstrated repeatedly in laboratories around the world, verified by countless experiments that consistently produce results no one quite knows how to explain. In the realm of quantum mechanics, particles don't have definite positions or velocities until they're measured, existing instead in what physicists call superpositions, ghostly probability clouds that encompass all possible states simultaneously. An electron doesn't orbit an atom like a tiny planet following a predictable path. Instead, it exists as a mathematical wave function that describes the probability of finding it at various locations when someone finally decides to look. This probabilistic nature of quantum reality extends to time itself, creating phenomena that challenge our most basic assumptions about cause and effect, past and future, the very foundations of temporal experience. But here's where things get truly puzzling. In most quantum mechanical equations, time appears as a parameter, a background variable against which quantum processes unfold. But it's not itself subject to the strange rules that govern quantum particles. Time, in standard quantum mechanics, remains classical, absolute, flowing steadily like Newton imagined it, even while everything else in the quantum world becomes fuzzy, uncertain, probabilistic. This creates an odd asymmetry in our description of reality, where space and matter follow quantum rules, but time marches along classically, immune to the weirdness that affects everything else. The real strangeness emerges when physicists try to merge quantum mechanics with Einstein's general relativity, attempting to create a theory of quantum gravity that describes how space-time itself behaves at the quantum level. When you apply quantum principles to the fabric of space-time, something remarkable and disturbing happens. Time disappears from the mathematics entirely. The Wheeler-DeWitt equation, which represents one attempt to describe the quantum state of the entire universe, contains no time variable whatsoever. It's completely timeless, describing a static, eternal quantum state with no before or after, no beginning or end, no temporal evolution at all. This presents physicists with what they call the problem of time in quantum gravity. If the fundamental equation describing the universe is timeless, then where does our experience of temporal flow come from? How do we get from a timeless mathematical description to the rich, dynamic, ever-changing reality we actually inhabit? Some physicists suggest that time is emergent, arising from the complex interactions of quantum systems in much the same way that temperature emerges from the random motions of molecules. Individual atoms don't have temperature, but when you have trillions of them moving randomly, temperature becomes a useful way to describe their collective behavior. Similarly, time might emerge from quantum entanglement, that mysterious phenomenon where particles become connected across arbitrary distances, instantly affecting each other regardless of how far apart they are. Some theories propose that as the universe evolves and particles become increasingly entangled with each other, this growing web of quantum connections creates the arrow of time, the sense of temporal direction that distinguishes past from future. In this view, time isn't fundamental but arises from the universe's increasing complexity, its growing network of quantum relationships. Other researchers explore the possibility that consciousness itself plays a crucial role in creating temporal experience. In some interpretations of quantum mechanics, the act of observation causes quantum superpositions to collapse into definite states, transforming probability waves into concrete realities. If consciousness is required to collapse quantum states, then perhaps consciousness is also required to create the experience of temporal flow. Time might not exist in an empty universe, but emerges only when conscious observers are present to witness and measure change. This leads to some fascinating thought experiments about the nature of time and awareness. If a quantum system evolves in complete isolation, with no conscious observers to measure it, does it experience time? Does time exist in regions of the universe where no sentient beings are present to witness temporal passage? These questions push us toward considering whether time is more like a sensory experience than a fundamental physical property, more like color or sound than like mass or electric charge. The many worlds interpretation of quantum mechanics offers another perspective on time's nature. In this view, every quantum measurement causes the universe to branch into multiple parallel realities, each containing a different outcome of the measurement. There's no randomness in this picture, just an infinite splitting of timelines, creating a vast multiverse where every possible sequence of events actually occurs somewhere. Time becomes not a single river but an enormous tree with countless branches, each representing a different possible history. From this many worlds perspective, the question, is time real, becomes more complex. Time within each branch might be perfectly real, following its own consistent timeline, but the overall structure of reality includes all possible timelines simultaneously. You exist not as a single thread moving through time, but as an infinite collection of variants, each following their own temporal path through their own version of reality. Quantum mechanics also introduces the possibility of time's granularity, the idea that time might not be infinitely divisible but composed of discrete, indivisible units called Planck time intervals. These quantum moments would be unimaginably brief, about 1043 seconds, but they suggest that time might have a fundamental structure, a basic rhythm or pulse at the deepest level of reality. If time is granular rather than smooth, then our experience of continuous temporal flow might be an illusion, like the apparent motion in films created by rapidly displaying still frames. Why does time seem to have direction, flowing always from past to future like a gentle river that never reverses course, never flows backward, never allows us to revisit yesterday or skip ahead to tomorrow? This question becomes even more puzzling when you realize that most of the fundamental laws of physics don't actually care which direction time flows. If you were to film two particles colliding and then play the recording backward, the backward version would look just as physically reasonable as the forward version. The equations of motion, the conservation laws, the basic rules that govern how matter and energy interact, all work equally well whether time moves forward or backward. Yet, in our everyday experience, time has an unmistakable arrow, a clear direction that distinguishes past from future with absolute certainty. Eggs break, but never spontaneously reassemble. Tea grows cold, but never heats up by itself. People age, but never grow younger. Books burn to ash, but ashes never leap together to form books. Memory works only backward, never forward. We can influence the future through our choices, but we can never change the past. This asymmetry is so fundamental to our experience that imagining it any other way seems absurd, yet physics suggests it should be possible for time to run in either direction. The key to understanding time's arrow lies in one of the most important and occasionally troublesome laws of physics, the second law of thermodynamics, which tells us that in any closed system, entropy always increases over time. Entropy is a measure of disorder, randomness, the number of ways that energy and matter can be arranged within a system. Think of it as a cosmic tendency toward messiness, a universal preference for chaos over order, for scrambled eggs over unscrambled ones, for mixed-up card decks over perfectly sorted ones. When you drop a glass and it shatters on the floor, entropy increases dramatically. The glass goes from a highly ordered state, with all its molecules arranged in a neat, crystalline structure, to a disordered state, with fragments scattered randomly across the floor and energy dissipated as heat and sound. The probability that those fragments would spontaneously leap back together to form a perfect glass is not zero, but it's so astronomically small that you could wait until the end of the universe and never see it happen. It's not that the laws of physics forbid such an event. It's that the statistics of probability make it virtually impossible. This statistical nature of time's arrow suggests something profound about the nature of temporal experience. Time's direction doesn't emerge from fundamental physical laws, but from the overwhelming likelihood that systems will evolve from more ordered states to less ordered ones. It's like watching sand fall through an hourglass. Each individual grain could theoretically flow upward, and the laws of physics wouldn't object, but the collective behavior of trillions of grains makes downward flow practically inevitable. This leads to one of the most intriguing and slightly unsettling questions in cosmology. Why was the universe in such a remarkably low entropy state to begin with? If entropy must always increase, then there had to be an initial condition of extraordinary order from which all this cosmic messiness could unfold. The early universe, just after the Big Bang, was incredibly smooth, uniform, and organized compared to the clumpy, chaotic cosmos we see today. Stars, galaxies, planets, and all the complex structures that make up our universe formed as gravity pulled matter together, increasing entropy in the process. But why should the universe have started in such an improbable, highly ordered state? This question, known as the past hypothesis, remains one of the deepest mysteries in physics. Some cosmologists suggest that the answer lies in the nature of the Big Bang itself, that the initial conditions were somehow inevitable given the quantum mechanical processes that might have triggered cosmic inflation. Others propose that our universe is just one bubble in an infinite multiverse, and we happen to find ourselves in a region where the initial entropy was low simply because high-entropy regions wouldn't produce the complexity necessary for conscious observers to evolve. There are other arrows of time besides the thermodynamic one, and remarkably, they all point in the same direction. The psychological arrow of time ensures that we remember the past, but not the future. This asymmetry exists because memory formation is a physical process that increases entropy. When your brain encodes a memory, it creates new neural connections, stores information in molecular structures, and dissipates energy as heat. These physical traces of past events can only be laid down after the events occur, which is why we can remember yesterday but not tomorrow. The causal arrow of time dictates that causes precede effects, that actions lead to consequences rather than the other way around. You flip a light switch, and the light turns on. You don't turn on a light and then decide to flip the switch. This temporal ordering of cause and effect also follows from the increase of entropy. When you flip the switch, you're adding energy to a system, and that energy spreads out and dissipates, increasing the overall disorder of the universe. The cosmological arrow points in the direction of the universe's expansion. Galaxies are moving away from each other. Space itself is stretching and cooling, and this cosmic expansion gives a clear sense of direction to time on the largest scales. If the universe were contracting instead of expanding, some physicists speculate that we might experience time running backward, though this remains highly speculative. What's remarkable is that all these different arrows of time align with each other. Thermodynamic entropy increases in the same direction that memory works, that causation flows, and that the universe expands. This suggests that time's arrow isn't just a random feature of our local environment, but something deeply connected to the structure and evolution of the cosmos itself. Your body doesn't just experience time, it creates it, weaves it, lives it from the inside out in ways so intricate and fundamental that you carry within yourself an entire temporal universe, a collection of biological clocks and rhythms and cycles that have been keeping time for millions of years, long before humans invented mechanical clocks or atomic standards or digital displays. These internal timekeepers are so sophisticated, so precisely calibrated to the rhythms of Earth and cosmos, that they continue running even in complete isolation from external time cues, maintaining their ancient rhythms in darkness, in caves, in windowless rooms where day and night lose all meaning. The master conductor of your biological orchestra is a tiny cluster of cells called the suprachiasmatic nucleus, tucked away in your hypothalamus just above the point where your optic nerves cross. This neural timekeeper, no larger than a grain of rice, contains about 20,000 neurons that fire in coordinated waves roughly every 24 hours, creating the fundamental rhythm that governs your sleep, your hunger, your body temperature, your hormone production, your mood, your alertness, even your susceptibility to disease and your response to medications. But your body contains not just one clock, but thousands of them, distributed throughout your organs and tissues, like a synchronized orchestra of temporal musicians. Your liver has its own circadian rhythm that anticipates when you typically eat, preparing digestive enzymes and metabolic processes hours before your usual meal times. Your kidneys adjust their filtering and hormone production according to daily cycles. Your immune system follows temporal patterns, with some immune functions stronger during the day and others more active at night. Even individual cells throughout your body contain molecular clocks, tiny genetic timekeepers that oscillate with roughly 24-hour periods. These cellular clocks are built from feedback loops of gene expression, where certain genes activate proteins that eventually suppress the very genes that created them, creating oscillations that pulse like molecular metronomes. The discovery that nearly every cell in your body contains these genetic timekeepers was one of the most surprising findings in modern biology, revealing that temporal rhythm isn't just a feature of nervous systems or complex organisms, but a fundamental property of life itself. What's particularly fascinating is that these internal clocks don't run on exactly 24-hour cycles when isolated from external cues. Most humans have natural rhythms of about 24 hours and 10 to 20 minutes, slightly longer than an actual day. This means that if you lived in a cave with no clocks, no sunlight, no way of knowing what time the outside world considered it to be, you would gradually drift out of sync with Earth's rotation, going to bed and waking up slightly later each day until your internal schedule had completely rotated through the 24-hour cycle. Light exposure is what keeps your internal clock synchronized with the external world, and the timing of that light exposure makes all the difference. Morning sunlight hitting your eyes sends signals through the optic nerve to your suprachiasmatic nucleus, essentially resetting your biological clock each day and keeping it aligned with the solar cycle. This is why jet lag feels so disorienting. When you fly across multiple time zones, your internal clocks are suddenly out of sync with your environment, creating a temporal conflict where your brain thinks it's midnight while the sun insists it's noon. Different parts of your body adjust to new time zones at different rates, creating a complex process of internal temporal reorganization. Your central nervous system clock might reset relatively quickly, within a few days, but your digestive system, your liver, your kidneys, might take a week or more to fully adjust to the new schedule. During this adjustment period, you exist in a state of internal temporal chaos, with different organ systems living in different time zones, creating the fatigue, confusion, and digestive upset that characterize jet lag. Modern life, with its artificial lighting and screen-based entertainment, creates a kind of chronic low-level jet lag for many people. The blue light emitted by phones, computers, and LED bulbs mimics sunlight and can suppress the production of melatonin, the hormone that makes you feel sleepy. When you look at bright screens in the evening, you're essentially telling your biological clock that it's still daytime, shifting your natural rhythm later and making it harder to fall asleep at what society considers appropriate bedtime. Individual differences in circadian rhythms help explain why some people are natural early risers while others are night owls. These chronotypes appear to be partly genetic, determined by variations in the genes that control your molecular clocks. If you're not a morning person, it's not a character flaw or a lack of discipline. Your genes may simply program your biological clocks to run on a different schedule than society's expectations. Your peak alertness, your best physical performance, your most creative moments might naturally occur later in the day than the conventional 9-to-5 schedule assumes. The influence of biological time extends far beyond sleep and wakefulness. Your body temperature rises and falls in daily cycles, typically reaching its lowest point in the early morning and its highest in late afternoon. This is why athletic performance often peaks in the late afternoon when body temperature is highest, and why early morning workouts can feel particularly challenging. Your blood pressure follows circadian patterns. Your immune system varies its activity throughout the day. Your sensitivity to pain changes with the time, and even your susceptibility to heart attacks and strokes shows clear temporal patterns. There's a growing field called chronopharmacology that studies how the timing of medication affects its effectiveness. The same drug given at different times of day can have dramatically different effects because your body's ability to absorb, metabolize, and respond to medications varies with your circadian rhythms. Cancer chemotherapy might be more effective and less toxic when timed to match the patient's biological rhythms. Blood pressure medications might work better when taken in the evening rather than the morning. This biological dimension of time reveals something profound about the relationship between consciousness and temporal experience. You don't just observe time, you embody it, participate in it, create it through the rhythmic processes of your own physiology. Your experience of now, of the present moment, emerges from the synchronization of countless biological clocks, each keeping its own rhythm while contributing to the larger temporal symphony that is your living, breathing, temporally embedded existence. The way we talk about time might actually create it, might shape it into the form we experience, might be one of the most fundamental ways human consciousness constructs the temporal reality we inhabit. This isn't merely a philosophical speculation, but a profound possibility that linguists, cognitive scientists, and anthropologists are taking increasingly seriously as they discover just how deeply language shapes perception, how the words we use to describe reality might actually determine the reality we're able to experience. Consider how naturally, how automatically you think of time as something you can spend, save, waste, or lose, as though it were a precious commodity flowing through your life like coins through your fingers. English, along with most Western languages, treats time as a resource, a substance that can be measured, divided, allocated, consumed. We talk about having time, making time, running out of time, as though temporal experience were a finite quantity that we possess and control. This metaphorical framework is so deeply embedded in our language that we rarely notice how strange it is to think of time as something you can own or manipulate. But this way of speaking about time creates a particular relationship with temporal experience, one characterized by scarcity, urgency, the constant awareness of time slipping away, the pressure to use time efficiently and productively. Other languages construct entirely different relationships with temporal reality. Some indigenous languages have no future tense as we understand it, no grammatical way to clearly distinguish between events that have happened and events that might happen. This doesn't mean speakers of these languages can't think about the future, but rather that their language doesn't force them to constantly categorize experiences as definitively past or future. Instead, they might use grammatical markers that indicate degrees of certainty, proximity, or relevance rather than temporal location. The Aymara people of the Andes have a particularly fascinating relationship with temporal direction. When speaking about the future, they gesture behind themselves, toward what they cannot see, while the past is gestured toward in front, toward what is visible and known. This seems backwards to speakers of European languages, but it makes perfect logical sense. You can see the past, know it through memory and experience, while the future remains hidden, unknowable, behind you where you cannot observe it. This linguistic and gestural tradition suggests a completely different way of experiencing temporal flow, where the past is present and visible, while the future remains mysterious and unseen. Hopi language, spoken by Native American peoples of the southwestern United States, reportedly has no grammatical tense system as European languages understand it. Instead of dividing events into past, present, and future, Hopi grammar focuses on the validity, certainty, and type of knowledge the speaker has about events. Rather than asking when something happened, Hopi might be more concerned with how the speaker knows about it, whether it was witnessed directly, heard as a report, or inferred from evidence. This creates a very different relationship with time, one that emphasizes knowledge and certainty rather than temporal sequence. Some linguists argue that these differences in temporal language create fundamentally different ways of experiencing time itself. The Sapir-Whorf hypothesis suggests that the structure of language influences thought, that the grammatical categories available in your native language shape the categories of experience available to your consciousness. If your language constantly forces you to specify whether events are past, present, or future, You develop a consciousness that automatically categorizes all experience temporally. If your language emphasizes certainty and evidence rather than temporal location, you develop a different kind of temporal awareness. But the relationship between language and time goes even deeper than grammatical structure. The very act of speaking creates temporal experience through rhythm, sequence, the unfolding of meaning across time. Every sentence you hear, every story you tell, every conversation you participate in creates a miniature temporal universe with its own beginning, middle, and end. Language doesn't just describe time. It enacts it, performs it, brings it into being through the sequential flow of words and meanings. Storytelling might be one of the most fundamental ways humans create temporal experience. When you tell a story about something that happened to you yesterday, you're not simply reporting past events, but recreating them, bringing them into the present moment through the magic of narrative. The story creates its own temporal flow, its own rhythm, its own sense of beginning and ending that might be completely different from the actual temporal structure of the events being described. A story can compress hours into minutes, expand moments into detailed explorations, rearrange sequences for dramatic effect, create temporal connections between events that were separated in actual time. This narrative dimension of temporal experience suggests that human consciousness might be fundamentally temporal, not because we exist in time, but because we are constantly creating time through the stories we tell ourselves about our experience. Your sense of personal identity, your feeling of being a continuous self that persists through change, might depend on your ability to construct coherent narratives that connect past experiences to present awareness to future possibilities. Without this narrative capacity, without the ability to tell yourself the story of your life, personal identity might dissolve into a series of disconnected moments with no temporal unity. Memory itself might be more narrative than photographic, more constructed than recorded. Each time you remember something, you're not accessing a fixed record of past events, but recreating those events through the lens of present consciousness, influenced by everything you've learned and experienced since the original event occurred. This means that your memories are constantly changing, constantly being rewritten, constantly being shaped by the temporal perspective from which you remember them. Dreams offer another fascinating window into the relationship between consciousness and temporal construction. In dreams, time behaves according to narrative logic rather than physical causality. Events can unfold in impossible sequences, past and future can intermingle, causation can flow backward, duration can expand and contract according to emotional significance rather than mechanical measurement. Yet these temporal impossibilities feel perfectly natural while you're dreaming, suggesting that waking temporal experience might also be more constructed, more flexible, more dependent on consciousness than we usually recognize. Neuroscientists are mapping time in the brain with increasing precision, and what they discover reveals a temporal architecture so complex and distributed that it challenges our basic assumptions about how consciousness creates the experience of flowing time. Unlike other sensory experiences that have dedicated neural hardware, a specific visual cortex for sight or auditory cortex for hearing, time perception emerges from networks scattered throughout the brain, working together to construct the seamless temporal experience that feels so natural, so immediate, so obviously real, that you never question how your 3-pound collection of neurons manages to create it. There's no single time center in your brain, no temporal equivalent of the visual cortex where all temporal processing happens. Instead, different brain regions handle different aspects of temporal experience, from millisecond timing needed for speech perception to circadian rhythms that span 24 hours, to the long-term temporal perspective that allows you to plan for retirement or remember your childhood. These various timing systems operate at different scales and use different neural mechanisms, yet somehow they coordinate to create the unified temporal experience of consciousness. Your brain predicts the future constantly, automatically, unconsciously, running thousands of temporal calculations every second to navigate the world successfully. When you reach for a glass of water, your motor cortex calculates the trajectory your hand will follow, predicting where the glass will be when your fingers arrive. When someone speaks to you, your auditory system anticipates the rhythm of their speech, the likely completion of their sentences, the temporal patterns of their accent and intonation. This predictive machinery might be one of the key mechanisms through which consciousness creates the sensation of flowing time. The brain's default mode network, that collection of interconnected regions that becomes active when you're not focused on any particular task, might play a crucial role in temporal experience. This network, which includes areas involved in memory, self-reflection, and mental time travel, becomes active when you're daydreaming, remembering the past, imagining the future, or simply letting your mind wander. Some researchers suggest that the default mode network creates the experience of narrative time, the sense that your life has a coherent temporal structure connecting past experiences to future possibilities. When this network's activity changes, temporal experience changes dramatically. Deep meditation can quiet the default mode network, leading to experiences of timelessness, of pure present moment awareness, where past and future dissolve into an eternal now. Psychedelic experiences often disrupt default mode network activity, creating altered states of consciousness, where time loops, speeds up, slows down, or disappears entirely. People report experiencing lifetimes in minutes, or minutes that feel like lifetimes, or moments of complete temporal dissolution where the very concept of duration becomes meaningless. Certain brain injuries provide natural experiments in temporal perception. Damage to the hippocampus, crucial for memory formation, can destroy the ability to form new temporal memories while leaving moment-to-moment awareness intact. Patients with severe hippocampal damage live in a perpetual present, unable to remember events that happened minutes ago or plan activities for the immediate future. Their consciousness becomes temporally fragmented, capable of experiencing now but unable to connect present moments to past or future experience. Parkinson's disease affects the brain's ability to produce dopamine, and among its many symptoms is a disruption of temporal processing. Patients often have difficulty with rhythm, timing, and temporal sequence. They might freeze in doorways, unable to initiate the temporal flow of walking, or have trouble with the rhythmic aspects of speech. This suggests that dopamine plays a crucial role in the neural mechanisms that create temporal experience, that the neurotransmitter systems that regulate movement and motivation also contribute to time perception. The phenomenon of flow states, those periods of complete absorption in activity where time seems to disappear, reveals something important about the relationship between attention and temporal experience. When you're fully engaged in something challenging and rewarding, whether it's playing music, writing, sports, or conversation, your brain stops its usual temporal monitoring. The networks that normally track time and maintain temporal awareness become less active, allowing consciousness to become completely immersed in present moment experience. This suggests that temporal awareness might require a kind of metacognitive monitoring, a part of your consciousness that steps back from immediate experience to track duration, sequence, and temporal relationships. When this monitoring system becomes less active, either through flow states, meditation, or altered states of consciousness, the experience of flowing time can dissolve, leaving only pure awareness without temporal structure. Sleep offers another window into the brain's temporal architecture. During REM sleep, when most vivid dreaming occurs, the brain's temporal processing systems create impossible narratives where causation flows backward, where past and future intermingle, where duration expands and contracts according to emotional logic rather than physical time. Yet these temporal impossibilities feel perfectly natural while you're dreaming, suggesting that waking temporal experience might be more constructed than we realize. The brain's temporal prediction systems also explain why time perception can be so easily disrupted. Fever, fatigue, stress, excitement, boredom, all can alter the neural networks involved in temporal processing, creating experiences where time speeds up, slows down, or becomes distorted. If time were a fundamental feature of external reality that consciousness simply detects, like light or sound, these internal states shouldn't be able to affect temporal experience so dramatically. Some researchers propose that consciousness itself might be a temporal phenomenon, that awareness emerges from the brain's constant integration of past experience, present sensation, and future prediction into coherent moments of experience. In this view, consciousness doesn't exist in time, but rather creates time through its integrative activity. Each moment of awareness combines memory traces from the recent past, sensory information from the present, and predictive models of the immediate future into the unified experience you call now. This temporal integration theory suggests that the present moment isn't a point in time, but a duration, a span of neural activity that binds together information from different temporal sources. The specious present, as psychologists call it, might last anywhere from a few hundred milliseconds to a few seconds, representing the temporal window within which the brain can integrate information into unified conscious experience. This integration process might be what creates the feeling of temporal flow, the sense that moments arise, peak, and fade away as consciousness moves from one integrated experience to the next. Our modern world runs on synchronized time with a precision that would have been unimaginable to previous generations. Yet this very precision reveals just how constructed, how artificial, how fundamentally collaborative our relationship with temporal reality has become. Every device around you, from the smartphone beside your bed to the GPS satellites orbiting overhead, participates in an intricate dance of temporal coordination that requires constant adjustment, continuous recalibration, and shared agreement about what time actually means in a universe where Einstein's relativity ensures that no two observers can ever experience exactly the same temporal flow. GPS satellites, those quiet guardians of modern navigation circling Earth every 12 hours, must account for time dilation effects that would seem impossibly subtle yet accumulate into errors of several kilometers per day if left uncorrected. Each satellite carries atomic clocks accurate to nanoseconds, but because they orbit at high speeds and experience weaker gravitational fields than Earth's surface, time passes slightly differently for them than for you. The satellites age faster than Earthbound clocks by about 38 microseconds per day due to gravitational effects, but slower by about 7 microseconds per day due to their orbital velocity. The net result is that satellite clocks run fast by about 31 microseconds daily, requiring constant correction to maintain the precision that allows your phone to know exactly where you are. Computer networks spanning continents synchronize their activities, using protocols that can coordinate actions to within microseconds, creating a kind of artificial temporal unity that bridges vast distances and different reference frames. When you send an email, make a video call, or stream a movie, countless servers and switches coordinate their timing using network time protocol, constantly checking and adjusting their clocks against authoritative time sources, creating the illusion of simultaneity across a globe where simultaneity, as Einstein showed us, is always relative to the observer's reference frame. High-frequency trading in financial markets has pushed temporal precision to extraordinary extremes, where microsecond advantages in execution time can mean the difference between profit and loss. Trading algorithms compete not just on the logic of their strategies, but on the speed of their temporal responses, leading to technological arms races where firms spend millions to reduce network latency by fractions of milliseconds. Some trading companies locate their servers as close as possible to exchange data centers, because even the time it takes light to travel an extra few meters through fiber optic cables can provide a competitive disadvantage. In these rarefied realms, time becomes a commodity more precious than the securities being traded. Yet all this technological precision serves human activities that ultimately happen in psychological time, in the subjective temporal experience of consciousness, that bears little resemblance to the atomic standards and synchronized protocols underlying our digital infrastructure. Your smartphone claims to know the exact time down to fractions of a second, displaying those numbers with confident precision, but that time represents a collaborative fiction maintained by international agreements, atomic measurements, and constant technological effort. The International Atomic Time Standard, which defines the second as the duration of exactly 9, 192, 631, 770 periods of radiation corresponding to the transition between two energy levels of the cesium-133 atom, provides a temporal foundation so precise that it would lose less than 1 second over tens of millions of years. But even this atomic precision requires human interpretation and coordination. Coordinated universal time, the standard that synchronizes global activities, occasionally adds leap seconds to stay aligned with Earth's rotation, which varies unpredictably due to tidal effects, atmospheric changes, and geological processes. These adjustments remind us that even our most precise temporal standards remain tied to the particular rhythms of our planet, our solar system, our local cosmic neighborhood. The Internet creates its own temporal relationships that transcend geographical location. When you participate in a live video conference with people around the world, you're creating a shared temporal experience that exists somewhat independently of local time zones. The conversation unfolds in its own temporal rhythm, its own beginning and ending, its own sense of duration that might feel completely different from the clock time passing in each participant's location. Digital communications can also create temporal dislocations where messages arrive instantly but are read hours or days later, creating conversational rhythms that stretch across time zones and daily schedules in ways that would have been impossible before electronic communication. Social media platforms generate their own temporal structures through algorithms that curate and sequence information according to relevance rather than chronology. Your news feed doesn't present events in the order they occurred, but in an algorithmically determined sequence designed to maintain your attention and engagement. This creates a kind of artificial temporal narrative where the apparent timing and sequence of information reflects computational decisions rather than actual temporal relationships. The result is a mediated temporality, where your perception of what's happening when is shaped by corporate algorithms rather than natural temporal flow. Digital storage and retrieval systems create new relationships with memory and temporal experience. Every photo on your phone is time-stamped, every email archived, every search query logged, creating vast databases of personal temporal information that can be recalled and analyzed in ways that human memory never could. These digital traces of your temporal experience can be searched, sorted, and cross-referenced, creating new possibilities for understanding your own life's temporal patterns, while also raising questions about privacy, surveillance, and the commodification of personal temporal data. The always connected nature of modern digital life can create a sense of temporal compression, where past, present, and future blend together in streams of notifications, updates, and communications. The constant availability of information and entertainment can make it difficult to maintain the kind of temporal boundaries that previous generations experienced naturally through the rhythms of work and rest, seasonal changes, and limited access to information and communication technologies. We've built a technological infrastructure of unprecedented temporal precision to support human activities that increasingly lack clear temporal structure or boundaries. Many physicists now favor emergence as the key to understanding time's mysterious nature, suggesting that time isn't a fundamental ingredient of reality, but rather arises from more basic, deeper, perhaps ultimately timeless processes, much like wetness emerges from H2O molecules that aren't themselves wet, or like temperature emerges from atomic motion, even though individual atoms don't have temperature. This emergent view of time represents one of the most radical shifts in scientific thinking since Einstein's relativity, proposing that the temporal flow we experience so intimately, so constantly, so unavoidably, might be more like a shadow cast by deeper realities than a fundamental feature of existence itself. Carlo Rovelli, one of the most eloquent proponents of emergent time, suggests that temporal flow emerges from our thermal perspective on reality, from the fact that we are large, hot, complex beings observing a universe composed of countless small, cold quantum interactions. In his view, time isn't discovered in the universe, but created by the way information flows through complex systems like ourselves. We experience time because we're macroscopic observers embedded in thermodynamic processes that create irreversible changes, but from a more fundamental perspective, from the viewpoint of the quantum processes underlying all physical reality, there might be no time at all. This thermal theory of time connects temporal experience to the second law of thermodynamics and the statistical nature of entropy increase. When you observe a hot cup of tea cooling to room temperature, you're witnessing the statistical tendency of energy to spread out and distribute evenly. The countless molecular collisions that create this cooling process are individually reversible, but their collective effect creates an irreversible change that defines temporal direction. Time's arrow might emerge from our perspective as beings who interact with many particle systems through their statistical properties, rather than their individual quantum behaviors. Other physicists propose that time emerges from consciousness itself, that sentient observers are required to collapse the timeless quantum superposition of reality into experienced moments. In this view, the universe exists as a vast collection of quantum possibilities until conscious observation selects particular outcomes from the sea of potential realities. Time becomes not a stage on which consciousness acts, but something consciousness creates through its active observation, measurement, and experience. This consciousness-based theory of emergent time suggests that in regions of the universe where no conscious observers exist, time might not flow at all. Empty space between galaxies, devoid of any sentient beings to witness change and collapse quantum states, might exist in a kind of temporal suspension, a timeless quantum superposition where all possibilities coexist simultaneously. Time emerges only where consciousness exists to observe, measure, and experience change. Some researchers explore the possibility that time emerges from information itself, from the way complex systems process and store information about their environments and histories. In this information-theoretic approach, time isn't something that flows through systems, but something that systems create as they accumulate information and build internal models of their changing environments. Your brain, constantly processing sensory information and building predictive models of your surroundings, might create temporal experience as a side effect of its information processing activities. The holographic principle from theoretical physics offers another perspective on emergent time. Some theories suggest that all the information contained in a three-dimensional volume can be encoded on its two-dimensional surface, like a hologram that contains three-dimensional information in a two-dimensional medium. In this holographic view of reality, what we experience as temporal flow might be how information encoded on distant boundaries gets processed and decoded by complex systems within the holographic volume. Digital physics takes emergence even further, proposing that reality itself might be computational, that the universe might be running on something like a cosmic computer where space, time, matter, and energy are all emergent properties of underlying information processing. In this view, time becomes something like the refresh rate of the universal computation, the rate at which the cosmic program updates from one computational state to the next. Quantum gravity theories often lead to emergent time through different mechanisms. Loop quantum gravity suggests that space-time itself is quantized at the smallest scales, composed of discrete loops and nodes rather than continuous fabric. Time might emerge from the statistical behavior of these quantum geometric degrees of freedom, from the way quantum space-time networks evolve and change configuration. String theory approaches emergent time through the mathematics of higher dimensional spaces and quantum field theories. In some string models, our familiar three dimensions of space and one dimension of time emerge from more fundamental structures existing in higher dimensional spaces, where the distinction between space and time might not exist at all. The many-worlds interpretation of quantum mechanics offers its own version of emergent time, where temporal flow emerges from the constant branching of reality into parallel universes. Each quantum measurement causes the universe to split into multiple branches, each containing a different outcome. Time becomes the parameter that describes how these branches separate from each other, how the tree of parallel realities grows and divides. Causal set theory proposes that space-time is built from discrete causal relationships, from elementary events that can influence each other in specific patterns. Time emerges from the partial ordering of these causal relationships, from the network structure of which events can cause which other events. In this view, time isn't a dimension through which events move, but the pattern of causal connections between discrete moments of reality. All these emergent theories share a common insight, that the temporal experience we take for granted, the flowing present that seems so obviously real, might be more like a story consciousness tells itself about deeper, more fundamental processes that don't themselves involve time at all. This doesn't make time illusory in the sense of being false or unimportant, but rather suggests that time might be more like music than matter, more like meaning than mechanism, something that emerges from relationships and interactions, rather than existing as a fundamental feature of reality's deepest levels. The implications are profound and oddly liberating. If time emerges from consciousness, information processing, or statistical mechanics, rather than being built into reality's foundation, then our experience of temporal flow might be more flexible, more open to influence, more connected to awareness and understanding than we've assumed. Some cutting-edge theories suggest that our entire three-dimensional reality, including the time we experience flowing through it, might be encoded on a two-dimensional surface, like information stored in a hologram that creates the appearance of depth and dimension from patterns etched onto a flat boundary. This holographic principle, emerging from the strange mathematics of black hole physics and string theory, proposes something so counterintuitive that it challenges our most basic assumptions about the nature of space, time, and the reality we inhabit, yet it might hold the key to understanding why time feels so real when it might not exist at all in the deepest layers of physical law. The idea began with studies of black holes, those cosmic monsters whose gravitational pull is so intense that not even light can escape once it crosses the event horizon. Physicists discovered that all the information that falls into a black hole, every particle, every bit of data about the objects that disappear beyond the point of no return, is somehow encoded on the black hole's surface rather than in its interior volume. This seems impossible at first, like trying to store a library's worth of books by writing on the library's walls, but the mathematics works out precisely. The surface area of a black hole's event horizon, measured in units of Planck length squared, equals exactly the maximum amount of information that can be associated with that black hole. This discovery led to a startling generalization. Perhaps all of reality works this way. Maybe everything we experience as three-dimensional space, filled with objects that move through time, is actually encoded as information on a distant two-dimensional boundary, processed and projected to create the illusion of depth, volume, and temporal flow. Just as a hologram stores three-dimensional visual information in two-dimensional interference patterns, reality itself might be a holographic projection from information encoded on the boundary of our observable universe. In this holographic view, time becomes not a dimension we inhabit but a way of reading information, a parameter that describes how the patterns encoded on the boundary surface get processed and experienced by conscious observers embedded within the holographic projection. Think of it like watching a movie. The film strip contains all frames simultaneously, with no temporal flow, no before or after, just a collection of static images arranged in sequence. The projector creates the illusion of motion and temporal progression by displaying these static frames one after another, but the flow exists only in the viewing, not in the film itself. Similarly, the holographic boundary might contain all moments of what we experience as history, from the Big Bang to the heat death of the universe, encoded as static information with no intrinsic temporal ordering. What we experience as the flow of time might be how consciousness reads this information, how awareness processes the vast database of reality encoded on the cosmic boundary. The projector in this cosmic cinema is consciousness itself, creating temporal experience by accessing and interpreting the timeless information structure that underlies apparent reality. This has profound implications for understanding memory, anticipation, and the nature of personal identity across time. Your memories of childhood aren't traces of events that happened in the past and have since disappeared. They're access points to information that exists permanently on the holographic boundary, parts of the eternal database of reality that your consciousness can retrieve and experience. Your future isn't something that doesn't yet exist, but information already present on the boundary, waiting to be accessed, when your consciousness reaches the appropriate coordinates in its reading of the holographic data structure. The holographic principle also suggests new ways of thinking about death and the persistence of personal existence. If your entire life, from birth to death, exists simultaneously as encoded information on the boundary, then death doesn't represent the cessation of existence, but simply the completion of your information pattern. Everything you've ever been, every thought you've ever had, every experience you've ever undergone, continues to exist eternally in the holographic structure of reality, accessible in principle, though perhaps not in practice, to sufficiently advanced information processing systems. Recent developments in quantum gravity have provided mathematical support for holographic theories. The ADS, CFT correspondence, a precise mathematical relationship between certain theories of quantum gravity and quantum field theories, demonstrates that gravitational theories in higher dimensional spaces can be exactly equivalent to non-gravitational theories on their lower dimensional boundaries. This isn't just a useful calculational tool, but a fundamental equivalence, suggesting that the two descriptions represent the same physical reality viewed from different perspectives. Laboratory experiments in condensed matter physics have found holographic relationships in some quantum materials, where the behavior of electrons in three-dimensional crystals can be described exactly by theories defined on two-dimensional surfaces. These discoveries suggest that holographic emergence might be a general feature of complex quantum systems, not just an exotic property of black holes and cosmological models. The holographic principle also offers new approaches to understanding consciousness and its relationship to physical reality. If consciousness is the process by which holographic information gets decoded into experienced reality, then different conscious observers might access different aspects of the boundary information, creating different but equally valid experiential realities. Your consciousness might be reading one subset of the holographic database, while another observer reads a different subset, leading to different but compatible experiences of the same underlying information structure. This suggests that the question, "Is time real?" might be asking the wrong thing. Time might not be real as a fundamental feature of the boundary information, but it might be completely real as an aspect of how consciousness interfaces with that information. It's not that time is an illusion, but rather that time is the language consciousness uses to read the timeless encyclopedia of reality encoded on the holographic surface. In this view, your entire temporal experience, your sense of past and future, your feeling of moving through time from moment to moment, represents your consciousness's way of navigating through an information space that doesn't itself have temporal structure. Time becomes not something you exist within, but something you create as you read the eternal story of reality written on the boundary of existence itself. If time isn't real in the fundamental sense, if it's more like a story consciousness tells itself than a basic feature of reality's architecture, does any of this actually matter for how you live your life? How you experience your days? How you relate to the passage of moments and the aging of your body, and the accumulation of memories that form your sense of personal identity? The answer, surprisingly, is yes, and in ways that might be more practical, more immediately relevant to your daily experience than you might expect from such seemingly abstract theoretical considerations. Understanding that time might be constructed rather than fundamental can profoundly reduce anxiety about deadlines, aging, mortality, all those temporal pressures that create so much stress in modern life. When you truly grasp that the urgent deadline creating pressure in your chest might be based on an artificial temporal structure rather than some cosmic necessity, the stress doesn't disappear entirely, but it loses some of its grip on your nervous system. You can still meet the deadline, still participate in society's temporal agreements, but without the underlying existential panic that comes from believing you're racing against some fundamental force of nature. The fear of aging, that gradual awareness that time is carrying you inevitably toward physical decline and eventual death, transforms when you understand that your past self still exists somewhere in the block universe, that your childhood wonder and youthful energy haven't been destroyed by the passage of years, but remain eternally present at their own coordinates in space-time. This doesn't make aging less real as a biological process, doesn't eliminate the aches and limitations that accumulate over decades, but it can provide a different perspective on what aging means, a sense that nothing essential is being lost even as bodies change and lifespans progress. Mortality itself becomes less absolute when viewed through the lens of emergent time. If all moments exist simultaneously in some deeper reality, then death represents not the cessation of existence, but the completion of a pattern, the finishing of a story whose beginning, middle, and end all exist eternally within the structure of space-time. This perspective has comforted humans across cultures for millennia, but modern physics provides it with a kind of scientific validation that might make it more accessible to minds trained in empirical thinking. Meditation traditions have long taught that dissolving time awareness brings peace, that the deepest states of spiritual realization involve stepping outside the ordinary flow of temporal experience into timeless presence. Now, physics hints that these mystical insights might reflect something true about reality's deepest nature. When experienced meditators report achieving states of pure awareness without temporal structure, they might be accessing consciousness's ability to experience reality more directly, without the temporal interpretation that usually mediates between awareness and the information structure of existence. This scientific perspective on time's constructed nature can enhance meditation practice, making it easier to achieve states of flow, presence, and timeless awareness. Understanding that the rushing thoughts and temporal anxieties that disturb meditation might be products of consciousness's temporal interpretation rather than fundamental features of existence can make it easier to let them go, to rest in awareness itself, rather than the stories awareness tells about past and future. Practical applications extend to managing jet lag, shift work, and seasonal depression, all conditions that involve conflicts between biological rhythms and social temporal structures. Knowing that time zones are human constructions, that your circadian rhythms evolved to match natural light cycles rather than arbitrary political boundaries, can help you work more skillfully with your body's temporal needs, rather than forcing yourself to conform to external schedules that might conflict with your biological reality. The insights about time's flexibility can make you more present in relationships, less rushed in conversations, more accepting of life's natural rhythms, rather than the artificial pace imposed by clocks and calendars. When you truly understand that this moment is not disappearing into an irretrievable past but exists eternally in the structure of reality, you can inhabit it more fully, with less anxiety about time slipping away and more appreciation for the richness available right now. Understanding time's constructed nature can also reduce the regret and rumination that come from dwelling on past mistakes or missed opportunities. If the past isn't really past but continues to exist in the block universe, then past events aren't failures that have destroyed potential futures, but fixed features of reality that contribute to the complete pattern of your existence. This doesn't eliminate the value of learning from experience or making better choices, but it can reduce the emotional suffering that comes from wishing things had been different. Planning for the future becomes more relaxed when you understand that future outcomes already exist in some sense, that your efforts and choices contribute to shaping what's already there, rather than creating something entirely new. This perspective can reduce anxiety about uncertainty, while maintaining motivation for positive action. You're not racing to create a future before time runs out. You're participating in the eternal pattern of reality, discovering what's already encoded in the structure of existence. The practical psychology of time perception changes when you realize that your experience of duration is highly malleable, influenced by attention, emotion, and mental state. Instead of feeling victimized by time's apparent speed or slowness, you can learn to influence your temporal experience through mindfulness, engagement, and conscious attention to present moment awareness. Time becomes less like a river carrying you along, and more like a landscape you can navigate consciously. Professional performance can improve when you understand that flow states, those periods of optimal experience where time seems to disappear, represent natural ways of engaging with reality that don't require forcing or struggling against temporal pressure. Athletes, artists, and professionals in many fields report better performance when they stop fighting time and start dancing with it, working with their natural rhythms rather than against artificial schedules. Even sleep becomes more restorative when you approach it with an understanding that the boundary between waking and sleeping consciousness represents different ways of interfacing with the same underlying reality rather than complete breaks in existence. Dreams might not be meaningless neural static, but alternative ways of processing the information structure that underlies both waking and sleeping experience. Paradoxically, questioning time's fundamental reality might help you use temporal experience more wisely, more consciously, with greater appreciation for the mystery and beauty of whatever process creates the flowing present moment you inhabit, real or constructed, fundamental or emergent, absolutely genuine in its effects on the consciousness that experiences it. But here's the mystery that keeps physicists awake at night, the question that haunts the quiet hours when equations have been solved and theories have been tested, and yet something fundamental remains unexplained. If time is indeed an illusion, if it's nothing more than an emergent property of consciousness or a statistical artifact of entropy or a holographic projection from timeless information, then why is temporal experience so utterly convincing, so immediately real, so impossible to shake, even when your rational mind accepts that it might not exist at all? This is philosophy's hard problem of consciousness, applied to temporal experience, the seemingly unbridgeable gap between objective description and subjective experience that makes the question of time's reality both fascinating and frustrating. The comparison to consciousness studies isn't accidental. Just as neuroscientists can map every neural circuit involved in vision, describe the electrochemical processes that create visual perception, trace the flow of information from retina to visual cortex, yet still struggle to explain why there's something it's like to see red rather than just process electromagnetic radiation of a certain wavelength, physicists can describe all the mechanisms that might generate temporal experience without explaining why there's something it's like to experience duration, sequence, the flowing present moment that seems so immediate and undeniable. You can understand intellectually that your brain constructs temporal experience from neural oscillations, memory traces, and predictive models. You can accept that Einstein's relativity shows time to be relative rather than absolute, that quantum gravity theories suggest time might not exist at the fundamental level, that entropy and information theory provide mechanisms for temporal emergence. Yet despite all this theoretical knowledge, despite all the scientific evidence pointing toward time's constructed nature, you still wake up in the morning with the unshakable feeling that time is flowing, that the present moment is real and immediate, that past and future are fundamentally different from now. Some philosophers and scientists argue that asking why illusions feel real is meaningless, like asking why dreams seem convincing while you're dreaming, or why magic tricks look magical before you know how they work. In this view, the convincing nature of temporal experience is simply what we should expect from any well-functioning illusion. If consciousness constructs temporal experience for survival purposes, to navigate change and plan actions, then of course that construction would feel real and immediate. An unconvincing illusion of time wouldn't serve its biological function. But this explanation feels somewhat unsatisfying, perhaps because temporal experience is so much more than just practical navigation through change. Time isn't just a useful tool for planning and remembering. It's the very medium of experience itself, the canvas on which all consciousness unfolds. Every emotion, every thought, every sensation has temporal structure, duration, beginning and ending. Even the most abstract mathematical insights or mystical realizations happen in time, unfold across moments, have their own rhythm and pacing. The persistence of temporal experience across all cultures, all species with complex nervous systems, all states of consciousness from waking awareness to dreams to altered states, suggests something deeper than mere biological utility. Plants orient toward light and follow circadian rhythms without consciousness as we understand it. Animals migrate according to seasonal cycles, follow temporal patterns of feeding and mating and territorial behavior. Even bacteria exhibit temporal behaviors, responding to environmental cycles and timing their reproductive activities. If time is purely an illusion created by conscious minds, why does temporal organization appear throughout the biological world? Perhaps the question isn't whether time is real or illusory, but what kind of reality it represents. Time might be real in the same way that music is real. A symphony doesn't exist as a physical object you can touch or weigh, yet music has genuine effects on consciousness, emotion, behavior. It emerges from relationships between sounds, from patterns unfolding across duration, from the interaction between acoustic vibrations and auditory perception. Music is simultaneously subjective and objective, constructed and discovered, ephemeral and eternal. Similarly, time might be real as pattern, as relationship, as the structure that emerges when change meets awareness. It's not real as a thing, not fundamental like mass or electric charge, but real as process, as the way complex systems organize information about change and stability. Time becomes not a stage on which events perform, but the performance itself, not a river-carrying experience, but the flowing that experience does when it encounters the world. This perspective suggests that the hard problem of time might be dissolving the wrong distinction. Instead of asking whether time is objective or subjective, real or constructed, fundamental or emergent, we might ask how consciousness and physical processes collaborate to create temporal experience. Time might not be something that exists independently of awareness, or something that awareness creates from nothing, but something that emerges from the interaction between conscious systems and the changing world they inhabit. The mystery deepens when you consider that questioning time's reality requires temporal experience itself. You can't step outside time to evaluate whether it exists, can't find a timeless perspective from which to judge temporal claims. Every thought you think, every experiment you perform, every theory you develop unfolds in time, uses temporal concepts, assumes temporal relationships. Even the most sophisticated mathematical descriptions of timeless reality must be communicated through language that inherently involves temporal sequence, developed through research programs that take time, understood by minds that exist in temporal flow. This creates a kind of philosophical vertigo, where the very act of questioning time's reality seems to presuppose the reality of the thing being questioned. It's like trying to use language to prove that language doesn't exist, or attempting to think your way to the conclusion that thinking is impossible. The tools available for investigating time are themselves temporal, creating a circular situation where time's reality or unreality might be undecidable from within temporal experience. Perhaps this circularity isn't a problem to be solved, but a clue to be followed, pointing toward the possibility that time and consciousness are so deeply intertwined that neither can be fully understood without the other. That the question, "Is time real?" might be inseparable from the question, "Is consciousness real?" And both might find their answers not in choosing between reality and illusion, but in discovering new ways of thinking about what reality means. What would existence be like without time? And is such a thing even imaginable for creatures like ourselves, who seem to breathe temporality like air, whose every experience unfolds across moments, whose very identity depends on the continuity of memory, connecting past to present to anticipated future? This question isn't merely theoretical speculation, but touches on some of the most profound experiences reported by mystics, meditators, and individuals who have encountered altered states of consciousness where ordinary temporal awareness dissolves, leaving behind something that seems more fundamental, more peaceful, more connected to the essential nature of existence itself. Mystical traditions across cultures describe states of consciousness where time seems to stop, where the ordinary flow of moments gives way to an eternal present, so complete and satisfying that past and future become not just irrelevant but inconceivable. These aren't brief lapses in temporal awareness, but extended periods of what practitioners describe as timeless being, where consciousness exists in pure presence without duration, without sequence. without the constant mental movement from what was to what will be that characterizes ordinary awareness. In deep meditation, experienced practitioners report reaching states where temporal monitoring simply stops, where the part of consciousness that usually tracks duration and sequence becomes quiet, leaving awareness resting in what they describe as the eternal now. This isn't unconsciousness or trance, but a heightened state of clarity where consciousness knows itself without the mediation of temporal concepts. Meditators often emerge from these experiences with profound difficulty estimating how long they've been sitting, whether minutes or hours have passed, because temporal measurement becomes meaningless within timeless awareness. Near-death experiences frequently include descriptions of timeless realms where experiencers encounter deceased relatives, review their entire lives, or receive profound teachings, all of which seem to occur outside ordinary temporal flow. People report experiencing lifetimes of information and emotion in what medical monitoring indicates are only minutes or seconds of clinical death. These accounts consistently describe reality as more real than ordinary waking consciousness, not less, suggesting that timeless experience might reveal rather than obscure the deepest nature of existence. Psychedelic experiences induced by various substances often produce dramatic alterations in temporal perception, from time loops where the same moment seems to repeat endlessly, to experiences of deep time where geological epochs unfold in inner vision, to complete temporal dissolution where the concepts of before and after become meaningless. Users frequently report that these non-ordinary temporal states feel more authentic than everyday time consciousness, as though they've glimpsed the timeless ground from which temporal experience emerges. What's particularly striking about these various reports of timeless awareness is the consistent description of profound peace, unity, and understanding that accompanies the dissolution of temporal experience. Rather than being frightening or disorienting, stepping outside time seems to provide relief from the anxiety, urgency, and restlessness that characterize ordinary temporal consciousness. It's as though the constant motion of temporal awareness, the endless journey from past to future, represents a kind of existential exhaustion that timeless presence resolves. In these states, people often describe experiencing their entire lives simultaneously, not as a sequence of events, but as a complete pattern where every moment is equally present and accessible. Childhood and old age coexist. Birth and death are revealed as arbitrary boundaries rather than absolute beginnings and endings, and personal identity expands beyond the narrow timeline that usually defines individual existence. The self becomes not a story unfolding through time, but a timeless awareness that is temporarily identified with a particular pattern of experience. These timeless states also frequently involve experiences of unity or interconnection, where the boundaries between self and other, observer and observed, dissolve along with temporal distinctions. Without the framework of sequential time to separate events and entities, reality appears as an undivided wholeness where everything exists in eternal relationship. Past and future actions, distant locations, other minds, all become immediately present and accessible within timeless awareness. Some mystics describe these experiences as remembering rather than discovering, as returning to a natural state of consciousness that temporal awareness has obscured rather than accessing something foreign or supernatural. In this view, timeless presence is our deepest nature, and the sense of moving through sequential time represents a kind of cosmic forgetfulness, a necessary but temporary identification with temporal process that allows for individual experience and development. Creative artists often report similar experiences during periods of deep inspiration, when artistic work flows seemingly by itself and hours pass unnoticed. Writers describe entering fictional worlds so completely that they lose track of time. Musicians speak of disappearing into music that plays itself. Visual artists become absorbed in creative process, where temporal monitoring stops, and only the immediate creative act exists. These flow states suggest that timeless awareness might be more accessible and more common than we usually recognize. Even in ordinary life, moments of profound absorption in beauty, love, or understanding can temporarily dissolve temporal awareness. Watching a sunset, holding a newborn child, experiencing deep emotional intimacy, contemplating mathematical or philosophical insights, all can produce brief experiences of timeless presence where the flowing present moment expands to encompass everything that matters. These various glimpses of timeless experience might offer insights into reality's true nature, suggesting that the eternal present, described by mystics, reflects something fundamental about existence that sequential time obscures. If consciousness normally creates temporal experience as a way of navigating change and complexity, then stepping outside that temporal construction might reveal the unchanging awareness that has always been present beneath the flow of moments. But perhaps the most significant aspect of these timeless experiences is their transformative effect on ordinary temporal consciousness. People who have tasted timeless presence often return to everyday time awareness with greater peace, less anxiety about the future, less regret about the past, more appreciation for the present moment. They seem to carry something of the timeless perspective back into temporal experience, creating a kind of temporal wisdom that honors both sequential time as practical necessity and eternal presence as ultimate reality. If time is how awareness creates meaning from eternity, then stepping outside time might reveal the eternal ground from which all experience arises, the timeless source that temporal consciousness reflects and expresses through the beautiful, complex, ever-changing dance of moments that we call life. So, is time real? After wandering through ancient philosophies and modern physics, through the corridors of consciousness and the mathematics of relativity, through quantum mysteries and biological rhythms and the deepest questions about the nature of existence itself, perhaps we've discovered that this isn't quite the right question to ask. Perhaps asking whether time is real is like asking whether music is real, whether stories are real, whether love is real. Questions that seem to demand simple yes or no answers, but actually point towards something more subtle, more beautiful, more mysterious than the categories of real and unreal can easily contain. Time might be real in the way that music is real, not existing in space like a mountain or a tree, but emerging from relationships, from patterns, from the interaction between change and awareness. A symphony doesn't occupy a location you can visit or have a weight you can measure, yet music moves us profoundly, shapes our emotions, creates meaning that can transform consciousness, and connect us to something larger than our individual experience. Music is neither purely objective nor purely subjective, but something that arises in the space between sound waves and listening minds, between acoustic vibrations and conscious appreciation. Similarly, time might be real as experience, as meaning, as the fundamental structure that allows existence to unfold in patterns we can recognize and participate in. It might not be fundamental like mass, or electric charge might not flow like a river or tick like a cosmic clock, but it could be completely real as the medium through which consciousness encounters change, growth, development, the endless creativity of existence expressing itself through sequence and duration and the precious present moment. Whether time emerges from entropy, from consciousness, from quantum entanglement, from information processing, or from mechanisms we haven't yet discovered. Whether it's holographic projection or statistical artifact, or fundamental feature of reality's deepest levels, time remains the canvas on which your life unfolds. It's the rhythm that makes existence beautiful, the framework that turns random events into your unique story, the invisible conductor that orchestrates the symphony of your days. Every breath you take, every heartbeat, every moment of awareness, every memory forming and every dream emerging, all of this happens in time or as time or through time, regardless of what physicists and philosophers eventually conclude about time's ultimate nature. The temporal structure of your experience, the way past connects to present to future, the way anticipation and memory create the continuity of personal identity, these remain profound and meaningful, regardless of whether they reflect fundamental features of reality or emerge from deeper, timeless processes. Even if time is an illusion, it's an illusion so complete, so functional, so beautiful in its effects, that calling it merely illusory seems to miss the point entirely. The stories we tell ourselves might be constructions, but they're constructions that create genuine meaning, real emotion, authentic connection between consciousness and the changing world. If time is a story consciousness tells itself about change, then it's a story worth telling, worth living, worth celebrating for its creativity and beauty, and endless capacity to surprise us. Your childhood wonder still exists somewhere in the block universe, or the holographic boundary, or the quantum superposition of possibilities. The love you've felt, the insights you've gained, the moments of perfect presence when time seemed to stop, all of this persists in whatever reality time occupies, whether fundamental or emergent, absolute or relative, real or constructed. Nothing beautiful is ever truly lost. It simply finds its place in the eternal pattern of existence, expressing itself through temporal experience. The question of time's reality might be less important than the question of how to live gracefully within temporal experience, how to dance with change rather than resist it, how to find peace in the flowing present while honoring memory and maintaining hope for the future. Whether time is real or illusory, whether it flows or emerges, or projects from timeless information, you still wake each morning to the gift of another day, still have opportunities to love and create and wonder and grow. Perhaps the deepest truth about time isn't whether it exists, but how it feels to be conscious beings embedded in temporal flow, how extraordinary it is that awareness can experience duration, can connect moments into meaningful sequences, can create continuity from change, and find beauty in the fact that everything, including this very moment, including your own precious existence, is temporary and therefore infinitely valuable. Time might be the universe's way of ensuring that everything doesn't happen at once, or it might be consciousness's way of reading the eternal story written in the structure of reality. Either way, it's the medium through which you encounter mystery, beauty, love, growth, discovery, all the experiences that make existence worthwhile. Whether fundamental or emergent, absolute or constructed, time gives shape to experience in ways that allow for meaning, connection, and the ongoing creativity of consciousness exploring itself through the endless dance of moments. So rest easy tonight, fellow traveler, through whatever time is or isn't, knowing that this moment, real or constructed, fundamental or emergent, is yours to experience fully. Whether you're floating on the river of absolute time, or participating in the collaborative construction of temporal reality, whether you're reading information from a holographic boundary or swimming in the flow of pure becoming, you are here now, aware and alive, part of the magnificent mystery of existence, unfolding through whatever beautiful process creates the experience of time. Sleep well and dream of tomorrow, that mysterious coordinate in the structure of reality, where new moments of wonder wait to be discovered, experienced, and treasured, however real or unreal they might ultimately be.